So dynamics deals with answering the question, why do objects move the way they do? So the question is, why do objects move the way they do? And there is one kinematics quantity that defines the type of motion, that is acceleration. So pretty much, why is acceleration not zero? That's one question. Why is acceleration zero? What causes that? Okay, so that's our big idea in this unit. So here we have the force. It's an interaction, pretty much, between two objects. Objects is a very loose definition in physics, in the form of push or pull. So since we have a direction, push or pull, force is a vector quantity, and then we have to apply vector math. All right. So what we do for notation in this course, that is, we'll use the letter F with an arrow on top to denote that it is a vector, and we'll have some sort of an index to show the type of force. All right. And the symbols that we use to draw a force, we'll use a arrow. All right, so for example, Fn for normal force. All right, the units for measuring force are newtons, and 1 newton is, as written there, 1 kilogram meters per second squared. All right, so that's a relationship between Newton and the basic quantities such as mass, length, and time. All right. It's worth noting here that a lot of us, we have this misconception of thinking that mass and weight are the same thing. So it's worth defining them. So mass is a measure of inertia, and also measure the quantity of matter contained in volume. And recall that inertia is the ability to resist changes in motion. All right. It's measured in kilograms, so the units are kilograms, not gram that you may use in chemistry. All right. So pretty much remember, even though in our everyday language we do use weight instead of mass, mass is not weight. All right. A mass is property of an object, is an intrinsic property. You carry it with you wherever you go in the universe. Whether is weight is the magnitude of gravitational force. All right, so that depends on the environment. All right, so weight depends on environment. All right. To give you an idea, if you go to the moon, let's say that the mass of a person is 100 kilograms, and the weight of that person is here on Earth. So let's put it on Earth. The weight is 980 newtons. If the same person goes to the moon, his mass is still 100 kilogram. However, his weight will be 980, roughly divided by 6 newtons, 6 times less. All right. So that is the difference between mass and weight.